Hi there, I'm Karen Greenhouse and welcome to Multiple Representations, using technology to help students make mathematical connections. I'm using a technology called Classpad.net. It is a free web-based dynamic math software. It lets you do any math that you want all in one space so that you don't ever have to leave the environment. You don't have to go to a different tool. You don't have to go to a different page. It's all able to be done in one place. So here I am on the landing page, and it is free for students and for teachers. You can just start exploring. So this is a great tool to use for distance learning if you just want to pull up a calculation or a graph or a geometry construction. You can start exploring. No sign-in needed. But if you want to save any of the work, students too, you do need to create an account. But if you just hit Start Exploring, let me explain what happens. You come to a page and it's a blank page. And that's because we want you to decide the math that you need to do. And to do that, you simply click somewhere on the screen and here are your options. You can do some calculations. You can do graphing. You can do, and I'm just going to click them so you can see what it looks like. So there's calculations. There's a graph. Here's geometry, it's a full geometry tool. Here's data, this is the table. So I have all these different things I can decide to do and I can move them wherever I want. I have unlimited space. So this is Classpad.net, everything you need in one space. So the best way to actually kind of see what I'm talking about as far as multiple representations, really helping students make mathematical connections because you can do many representations in one space and let them see those connections and relationships. So this is a ready-to-use activity. It's been shared via URL. It is in the handout if you look through the poster. So there's a link to this. But I wanted to show you what's in here. So here's text. So text is one representation. It's where students can write their observations. So notice there's directions in the text, but if we scroll down, there's also text boxes that allow students to write in their own thing. So text is one representation. Here's an example of a geometry sticky. This is a dynamic circle that was created because this is a full dynamic geometry software. It lets you do pretty much anything you would expect to be able to do with geometry. Over here is a data table. And one of the things that students really need to do is try to figure out the patterns and the relationships themselves by collecting their own data. So we've created a geometry visual that they can change, and then they're going to record the data. So we're going to just record one more data point here with this new circle. I'm using my computer keyboard to type in these numbers, and let's just collect this one more. You can, if you have a tablet, it would be the tablet keyboard. So now I'm in the data sticky, and I did want to show you, I want to now do a third representation. So we've got a visual, we've got data, and now we're going to look at that data in a plot, in a statistical plot. So I'm going to select my input and output, and I'm going to choose graph, but please notice that there are all these different things you can do in data, all the different tests and the regressions and the distributions all are there. We're going to go into graph, and we're going to choose scatter plot. So I have now made a statistical plot, so a third representation of my circle diameter relationship. Looks like they have a relationship linear, so maybe now you want to do a calculation. So without having to leave or change anything, I can pull up a calculation tool. So I'm going to click, choose the calculate, and here's my calculation sticky. Notice I can move things wherever I want, and that's a really great advantage because you can basically arrange your paper to be the way you want it to be. Put things next to what you're describing. So it's a really nice feature. So let's calculate what we think this relationship is. And here's where it's nice. Classpad is connected. So notice I'm going to use the labels that are up here in my data table. So I'm trying to find the ratio of circumference and diameter. So I'm going to define that ratio to be the circumference. Notice I'm using exactly, whoops, forgot to do my division. And notice it's nice standard. So now when I do it, what happens is it automatically calculates all the different values that were in my table, and it fills in that table column from my calculate. Everything is connected. So now it looks like I do have a very consistent rate, 3.14. So if that's the case, can I write a function? So yet another representation. So I've got my visual, I've got my data, I've got my data plot, and now I'm going to graph a function. And I'm going to let y equal circumference, and I'm going to let diameter be my x value. And so I'm going to enter using the calculation we came up with. And now you'll see that I have the graph of the function. And so now we can describe the function. How is it connected to the table? What do I need to think about? Does it make sense that my function, if we move this graph, goes past 0? Does that make sense in the context of this situation? So you can really start exploring and really helping them understand what the function does compared to the table, compared to the visual, and how do you limit things like that. And so another thing you can also do, again, multiple representation. Here is my function. I can hit the table of my function and compare it to my data table here. How are the values different? Do these values that are negative make sense? So this is an example of multiple representation. Please explore the poster, and if you have any questions, leave it in the poster chat. And I will be here live from 1:30 to 2:30 on Friday. Hope to see you there.